All right, so let's quickly take a look at the interpretation of these results. Now, here's a comprehensive walkthrough of every panel, okay, in the hackathon as far as this notebook is concerned, and interpreting what each visualization reveals about the current trends in AI, ML model development on Kaggle, and drawing out practical implications for practitioners and platform designers alike. Now, we have figure 1.1, the Kaggle Kernel and CSV Analysis graphical plots, as you can see on the screen. Now, firstly, you should understand that the monthly competitions versus kernel competitions, that's the top left, shows blue bars, a count of new competitions launched each month. All right, the orange line counts the distinct kernels submitted in the same period. Now, here are the key insights. The kernels outpace competitions. All right. Participants typically write multiple kernels per contest, on average of 3 to 5 kernels for every new competition. Now, let's look at the seasonal spikes. Noticeable, you see the peaks in March, August, and December, respectively. Then, coinciding with major seasonal contests, spring challenges, summer hackathons, year end pushes. Now, application implications, all right, what this actually means in real time. The rapid prototyping culture, the teams iterate quickly, suggesting that any tooling or template that accelerates initial model scaffolding, that's startup notebooks, will see high adoption. Infrastructure scaling, platform backends must provision additional compute resources during known peak months to maintain responsiveness. Another important thing there is the 3 month rolling average of competition, which launches and the kernel creations. All right, that's the top right. Now, what you see, it is smoothed curves showing long trends with short term noise filtered out. Here are the key insights: steady growth. Competitions climb at 8 per month on the average, kernels at 35 per month on the average. Then flattening seasonal dips. Rolling average softens, pronounced holiday season slowdowns, indicating an underlying constant upward trajectory. Application implications. Predictive capacity planning. Use rolling images to forecast compute and storage needs several months out. Now, trend detection. That's another application under this graph. You see that the early detection plateauing in either series could signal warning community engagement or need for new contest types. Now, let's look at the public versus the private score distribution histograms. That's the one in the middle left. This is what you see. Now, 2 overlay density plots: light blue for public letterboard scores, dark blue for private letterboard scores. Key insights: tighter public scores means around, let's say, 72% and low variance. Live feedback constraints large deviations. Broader private scores, larger spread, that's approximately 0.08, highlights the true test set performance, which discriminates better among high performance. Application implications: overfitting detection. Discrepancies between public and private distributions can guide the design of improved public score proxies to reduce letterboard overfitting. Then, the model selection strategies. Developers should prioritize maintaining generality, that's cross validation practices, rather than chasing marginal public score gains. Now, let's look at the next thing here, the time series of the median 90th percentile private score. That's the one in the middle right. What you see, solid green line, monthly median private score, dashed green line, monthly 90th percentile private score. Key insights: upward trajectory, median rises by 6 points, 90th percentile by 10 points over 2 years. Narrowing gap. The difference between median and a light performance shrinks, all right, implying trickle down of advanced techniques. Let's look at the application implications here. Here you see that the knowledge diffusion, high performing solutions become public faster, raising the bar for mid-tier competitors. Educational resource planning. Platform and community should invest in tutorials on emerging methods, new infrastructures or architectures to help median catch up. Unique users per competition. This is another plot. It's on the bottom left. What you see is a bar chart of distinct participating users for the top 20 competitions. Here are the key insights. Domain matters. Image classification and the NLP tags draw 2,800 users. Niche domains under 500. Community segmentation. Specialized problems require domain expertise, limiting broad participation. Now let's look at the application implications. Challenge design to maximize reach, balance domain novelty, okay, with accessibility, provide robust starter kits for domain specific contests. Onboarding focus. Create light versions of niche competitions for novices to cultivate interest before tackling full blown tasks. Now, let's look at another plot here, which is the kernel reuse rates across competitions. That's the one in the bottom right. What you see is a percentage of kernels forked at least once per contest. Key insights. Moderate reuse. Overall fork rate of 15% rises to 25% when starter notebooks are supplied. Collaboration incentives. Provision of quality templates strongly correlates with community engagement. Now, let's look at the real-time application or implications. Template strategy. Official starter notebooks boost reuse knowledge transfer, invest in high quality, well-documented templates for all contests. Mentorship programs encourage fork and augment workflows by spotlighting exemplary community kernels. All right, so let's go into the second part of this output, which shows the figure 2.1, the meta-kaggle hackathon full pipeline, CSV and code. The previous one focused on the CSV files, analysis of the CSV files. But here we're now combining the two, both the CSV files and actually the R and the notebooks, the Jupyter, JSON based, and of course the Python scripts. Let's look at the analytics plots. Now, first you see the library usage patterns, which is represented by the bar chart of top 10 most used libraries. That's top left. Now, what you see now is an adoption rate percentage of 10 imported libraries. Key insights: pandas at 85%, numpy at 78%, scikit-learn at 65% domination. All right. Then you now see TensorFlow and Python at 40%, showing growing traction in vision and time series challenges. Application implications. Curriculum focus. Training materials should emphasize mastery of these core libraries. Library support. Ensure platform environments pre-install and optimize these key packages. Library co-occurrent network at the top right. What is seen here are nodes representing libraries, edge thickness, encoding frequency of joint inputs. The key insights are the pandas numpy edge, which is thickest essential do of the manipulation. Strong scikit-learn MATLAB link highlights integrated modeling and visualization workflows. All right. Now, these are the application implications. You have dependency management. Platform can suggest installing complementary libraries together or auto-generate requirements.txt. Automated insights. Graph-based suggestions to new users. If you import pandas, consider importing matplotlib for quick plots. Now, let's look at the code complexity and development style, which is represented by the histogram of script length and cell count. That's the one at the bottom left. Now, what you're seeing here is overlay distribution, script LOC blue colored, and the notebook cell count, which is orange. These are the insights. The majority between 200 to 500 LOC and 15 to 25 code cells. Long tails beyond 2000 LOC signal monolithic kernels prone to maintainability issues. Now, let's look at the application implications here. Best practice guidelines encourage, you should encourage modular code, of course, and the functions classes to manage the LOC growth. Linting tools integrate warnings when notebooks exceed or recommend cell or LOC thresholds. Now, let's now look at the box plots of execution during by the file type. Okay, the one that is on the bottom right. Now, what you see here is the box plots for our scripts, the green. The Python scripts is blue, and the notebooks ipnyb, of course, is orange. All right, ipnyb, that's the extension. Now, these are the key insights. The notebooks median are roughly at 45 versus the Python at 18 and the R at 12. All right, these are the medians of these extensions, these file extensions. Then we have high variance in notebooks due to heavy outputs and high input and output, of course. Now, let's look at the application implications. Performance profiling. Offer built-in timers or cell profiles in notebooks to help users identify slow cells. Then environment tuning. You could actually use or suggest lightweight display settings or data caching mechanisms to speed up notebook runs. All right. Now, let's now move to the final aspect of this presentation, which of course focuses on the exploratory data analysis, represented by the figure 3.1, the meta-kaggle hackathon full part 9 continued. All right. Now, one of the first things we want to look at here is the user collaboration and insights. All right. The top contributions by kernel count, which is at the top left. What is actually seen here is the bar charts ranking users by total kernels authored. Now, one of the key insights here is that a small cohort of power users generates a disproportionate share of kernels, about 120 plus, and then application implications implies that the recognition programs, like feature top contributions in letterboards or community spotlights to incentivize quality sharing. All right, that's for the recognition programs. For the mentorship matching, it's actually recommended to connect novices to power users for onboarding help or code reviews. Now, let's look at the temporal heat map, all right, of kernel activity. That's hourly, daily, the one at the top right in this image you're seeing right now. Now, what you see is the heat map grid with days on the y-axis, all right, and hours on the x-axis, colored by kernel counts. Here are the major key insights. The peak activity is between Monday and Friday, okay, between the hours of 10 a.m. to 4 p.m. Universal Time, plus Sunday evenings, reflects globally distributed workloads and weekend wrap-ups. Application implications. Live support hours. Schedule. It is recommended that you schedule community office hours or live question and answer during peak windows. Compute reservations. Offer discounted credits for peak hours or flatten resource demand. Okay, Kaggle is actually, the management is recommended to do this. All right, now let's look at this feature correlation analysis. This correlation matrix of metadata features is at the bottom left, and what you see there is a heat map of pairwise Pearson correlations among LOC, run count, scores, and other features. These are the key highlights. The LOC Um, Run count, that's about 65% there. Longer kernels tend to be iterated more. The run count private score improvements, roughly at 45% iteration, correlates with better performance. Now let's look at the application implications. Iteration encouragement. It is recommended that you build dashboard widgets that track and reward frequent runs or commits. Okay, feature selection. Use these correlations to choose exploratory variables in predictive models of submission success. Let's look at the cluster dendrogram of feature groups, the one at the bottom right. Now, what you see is the hierarchical, sorry if I'm not pronouncing that right, the hierarchical clustering tree grouping related metadata features. Now, these are the key insights. You have the three clusters emerge, all right? Then you have complexity and iteration, okay? Library utilization and temporal engagement. The application implications is that the modeling roadmap tailors, it's better you tailor separate predictive models for each cluster. For instance, the complexity based model versus the temporal engagement model. For the dashboard design, it's recommended that you present users with grouped metrics so that they can quickly engage or gauge their code complexity versus their collaboration habits. Now, let's now discuss and finally conclude on these particular insight that we are looking at as far as this hackathon is concerned. All right, the metadata for Kaggle. Collectively, you should know that these visualizations reveal a maturing Kaggle ecosystem in which deep learning frameworks have risen steadily alongside traditional ML libraries. Iterative development, high run counts, is a strong signal of eventual submission success. Code complexity needs to be balanced with readability and execution speed. Community interactions, forks, power, user contributions, temporal patterns underpin knowledge diffusion. Practical takeaways for the AI ML model development include you should adopt the management should adopt modular templates, okay, scaffold kernels to minimize monolithic and speed up iteration, track and optimize execution times, integrate profiling tools into notebooks to keep runs snappy, leverage collaboration, fork and extend proven starter notebooks, participates in reuse networks. Then, of course, monitoring and managing the libraries is also very important because it makes the overall users and contributions to these competitions to stay current with the fast growing frameworks by following library usage trends. All right. So, in conclusion, this transforming these raw data into rich insights, platform engineers can actually platformize or prioritize rather tooling enhancements, and the educators can tailor training materials while competitors can gain clear data-driven stepwise guidance on the actual best practices that is focused and tailored for efficient and high performance model development. This concludes this presentation. Thank you very much. Have a lovely day. Have a lovely week ahead.
Audio